Okay, let's talk load screens and progress bars. So to get started, we're going to throw some progress bars up down below in a couple of different styles, and they'll keep updating throughout the video. You can watch them and see which ones seem more accurate, more engaging, and as we go, I will identify the different kinds of bars as we're using them. Why do you have these things at all? Well, the reality is there's quite a few things in software, but in games in particular, that take longer than a single frame to do. Maybe you're having to load a huge amount of data off a hard drive or download something off the internet. Maybe you have to do a bunch of processing work to assemble a level out of its component parts in real time. Maybe you have to build an encounter using the fuzzy logic that you have designed for your game to make sure that that encounter is a good challenge for them. All of these things are things that might take several seconds to do. You can't just freeze the game while you are doing them, so you need to do something. If it's short enough, you might just do a little spinny thing on the screen that says stand by, contacting servers, or saving game. And if it's just a time-consuming thing, but not a processor or hard drive consuming thing, you might be able to even do that while the game continues running. You do see that with a lot of saving in games these days, where the save happens in the background, the little spinny thing in the corner, but the game is continuing, you can keep going. But sometimes that's not possible, and in those cases, you need to do something more. So now you've got a load screen, and you have to ask yourself a question. Do you want to show the progress of the load or whatever work that you are doing? Often these days, actually that's not done. And we'll talk a little bit about why often that's not done. But let's say that you've decided that no, you want to do it, you want a progress bar so they know what they're in for. There are a few different ways to do progress bars. Let's talk about them, and maybe along the way you can understand why when you install an update for Windows, sometimes it moves really fast and then it sits there for a long time, and maybe this will start to make sense. So the first, and in some ways the easiest way to do a progress bar, is to just chunk it up. You've got 10 things you're going to need to do. You know about how long each of those are going to take. So you take your progress of 100% and you break it up into 10 chunks. You might make them each 10%, but if you know each part takes a different amount of time, you might make each chunk a different size. And then, as you go through whatever work you're doing, you put in points along the way where you update that progress bar. I've finished loading swords. That means I'm at step 1. I move the progress bar from step 0 to step 1, and we just keep doing that along the way. This causes the progress bar to move jerkily. It only moves in as many increments as you implement it. This was done a lot in the past because your game was probably only a single thread. So in order to update the progress bar, you needed to stop whatever you were doing in order to do so. Because you've put in these updates along the way, you basically know how far along you are, but this can get incredibly inaccurate. And why is that? Well, let's do an example. Let's say I'm loading a level, which requires me to load a bunch of data off of the hard drive, and then I'm going to do a bunch of processing on that data in order to put the level together correctly. And then finally, I'm going to contact a central server to get a final bit of data and find out some things that are stored on a central server. So that's 3 distinct things. When I am building the game, I can get times for each of those things, how long each of those things is going to take. So let's say in the standard development test, they take about the same amount of time. But now out in the wild, things are really different, because on my dev machine, everyone's got a solid state drive. We've all got not the best PCs, but we've got something that's pretty decent. And we've got a super fat connection to our servers. In fact, maybe when we were doing testing, we weren't even running the servers off site yet. Maybe they're just down the hallway. So the measurement of time is under those conditions. And I can obviously correct for that, but now it's out in the world, and maybe you have a non-solid state drive, a platter drive. So that time takes way longer, 3 or 4 times as long. But you've spent, even though you bought a crappy hard drive, you spent tons of money on your processor. So that processing time takes way less time. But you're running off your neighbor's Wi-Fi, so that part, which takes a few seconds in the office, is now going to take minutes. So what happens? The progress bar sits there, and then moves, and then it jumps the middle part really fast. And you're like, wow, this load is super fast. And then it grinds away forever, seemingly, on the last part. So even though you know how far along you are, it's very difficult for this kind of progress bar to be accurate. It's accurate to how far down the checklist you are, but you don't know how long each part of the checklist is going to take. So this style of progress bar is actually really good if you only have a single source of time. If you are just loading things off of a hard drive and then updating your progress bar throughout that load, this works pretty well, because if I have a slower hard drive, I don't, at the dev's side, know how long your load is going to take, but I know it's going to take proportionally the same amount of time. So the point at which I'm 50% of the way through the load is the same as the point where you are 50% of the way through the load, even if you have a much faster or slower hard drive. The place that this style of progress bar really breaks down is when there is several different sources of time that are highly variable, like hard drive and network speed and processor speed. If they're all getting slower at the same rate, then progress bar works fine. But if some of them are getting better and some of them are getting worse, depending on the person, then this style of progress bar becomes incredibly inaccurate. And this is basically what Microsoft does, which is why sometimes it seems to just hang there for a while, because your setup, for whatever reason, isn't the same as what they're using for their benchmarking. So maybe you have a worse network connection, or maybe the antivirus software kicked in the background and the hard drive is churning. For whatever reason, your experience is different from what they use to set up that progress bar advancement, and that's causing a lot of inaccuracy. A second option is to just guess. You've got another thread that you've got for rendering, so you've got the ability to do a progress bar update asynchronously from the work that you're doing. In testing, you know that the load takes somewhere between 30 seconds and 45 seconds. So you say, we're just gonna treat it as 45 seconds. We're gonna have the bar just smoothly update for 45 seconds, and it's gonna hit the end when the load is done. So if it takes 30 seconds, what's gonna happen is it's gonna get to 2/3 and just finish. That's not really a problem. This gives you a smoother loading experience. You feel like the game is doing something all the time. You never have these weird situations where you wonder if maybe it's crashed. But it's even more likely to be inaccurate because, of course, back out in the world, that person with the platter drive and the mediocre PC and the Wi-Fi connection from their neighbor is going to take way more than 45 seconds. And now what? The thing reaches the end. What do? Just hang there? Now you've got a real problem, or maybe you start over again. You can do something to at least make it look like it's not frozen, but again, hard to be accurate. This style of progress bar is really great if you actually have a pretty good idea of how long the thing is going to take in total, because it doesn't really matter how far along you are. If you know it always takes 5 minutes or somewhere between 4 and 6 minutes, then you can actually use this style of progress bar to give a feeling of response without a lot of work. But it tends to fall apart pretty fast if you don't know how long something is going to take in its totality. You can do improvements on either of these solutions to try to make it feel a little bit better. If you're doing the segmented progress, you could chunk it up and have a smooth bar within each of the segments to give that movement, and then just make it accurate again as you hit each of your milestones. You can. You may be wondering, well, why don't you measure how long things are taking on the person's actual hardware setup and then make this number more accurate. And you could do that. It would likely make the load take longer, and the reality is that people are so used to progress bars being this weird, inaccurate thing that it's not worth the effort to figure out how to do that in a way that actually improves the accuracy. You might also be wondering, well, why do a progress bar at all? Why don't we do something better? So it's important to know that all the console certifications have maximum amounts of time that you can go without entertaining the player, and even shorter amounts of time you can go without proving that you're not crashed. So whatever you're going to do, you're going to need to make sure that there is something moving on the screen. It could even just be a little rotatey thing. But also after 5 seconds or so, you're going to have to do something that engages the player. Often this is load tips or bits of lore or codex entries. Some games go and let you look at items from your inventory on this screen. What you don't see very often is movies. And you could have a movie that is unskippable that is the entire length of your load. So why don't you ever see this? Well, maybe it's obvious, but the reason you don't see this is because playing a movie is actually pretty intensive on your hard drive and potentially pretty intensive on your processing as well. So during your load, playing a movie on top of it is going to make your load take longer. And if this is a movie that is super engaging and you're only seeing this one time because it's part of the crit path, then that's probably fine. But if this is a movie you made just to cover your loads, taking your load from 20 seconds to 40 seconds and putting a 40-second long unskippable movie over top of it that they're seeing every single time they load is going to get old really fast. So it's doable, you can do it, but you have to remember that loading is just grinding the console. It's using up tons of hard drive, tons of memory, tons of processing time. So anything you're doing to engage the player needs to fit in a pretty small box, or it's going to impact the length of time your load actually takes. Now, for those of you who've been in the video game industry for a while, you might have this sort of niggling feeling in the back of your head that doesn't someone have a patent on playing minigames over load screens? And that's almost true. Namco had a patent for playing minigames over load screens, but that patent actually expired in 2015. So if you have something that is engaging to the player and you want to put that over the load screen, that's great. And I would recommend that ideally it be something that's relevant to the experience of the game. So this would be a good place to put places where they can try out some of their combat moves, or work on their inventory equipping, or read their codex, things that are somehow related to the overall experience, as opposed to just throwing asteroids up over top of the load screen and calling it a day. What we're seeing start to reoccur, it's something that was actually more common in very old games, is continuous loading, where there's load screens have disappeared entirely from some genres. And that's great, but that does require you to design around this fact, because as hardware gets better and better, rather than load times getting smaller and smaller, what's actually historically happened is that the amount that we load has just gotten bigger at about the same speed as the hardware has gotten better. So we haven't really made a ton of progress. It does still require special engineering to try to get rid of loads completely. So hopefully this was interesting and it gave you an idea of why your Windows update goes 1, 2, 3, 4, 12, 30, sits there for 20 minutes, jumps to 70, sits there for 20 minutes, jumps to 100. If you found this interesting, give it a thumbs up, because that will show YouTube that it's garnering some interest. A special thanks to my members. They provide the resources that this channel needs to keep running. If you are interested in becoming a member, there's a link down in the description. If there are any particular topics that you are curious about that feel like they are done poorly in games in general. Maybe I can shed some light on why maybe it's not quite so simple as you think. Leave a comment down below. If you found this interesting, share it with someone else that you think might find some value out of it. I will see you again soon. Thank you.